Hello friends, I am here again with the new topic of data science is exploratory data analysis. What is exploratory data analysis EDA? Exploratory data analysis EDA is used by data scientists to analyze and investigate data set and summarize their main characteristic of an employee data visualization method. EDA helps determine how best to manipulate data sources to get the answer you need, making it easier for data scientists to discover patterns, spot anomalies, test a hypothesis, or check assumptions. EDA is primarily used to see what data can reveal beyond the formal modeling or hypothesis tasking task and provides a better understanding of dataset variables and the relationships between them. It can also help determine if the statistical techniques you are considering for data analysis are appropriate. Originally developed by American mathematician John Turkey in 1970s, EDA techniques continue to be a widely used method in the data discovery process today. So this is the basic definition of EDA. Now we go through why is exploratory data analysis important in data science. The main purpose EDA is to help look at data before making any assumption. It can help identify obvious errors as well as better understand patterns within the data, detect outliers or anomalous events, find interesting relation among the variables. Data scientists can use exploratory data analysis to ensure the result they produce are valid and applicable to any desired business outcome and goals. EDA also helps stakeholders by confirming they are asking the right questions. EDA can help answer questions about standard deviation, categorical variables, and confidence intervals. Once EDA is complete and insights are drawn, its features can then be used for more sophisticated data analysis or modeling, including machine learning. Now we can see types of exploratory data analysis. There are mainly four types of exploratory data analysis is unvariate non-graphical, un, unvariate graphical, multivariate non-graphical, and multivariate graphical. So, unvariate non-graphical. This is simplest form of data analysis where the data being analyzed consists of just one variable. Since it's a single variable, it doesn't deal with cause of relationship. The main purpose of unvariate analysis is to describe the data and find patterns that exist within it. Unvariate graphical. Non-graphical methods don't provide a full picture of the data. Graphical methods are therefore required. Common types of unvariate graphics include stem and leaf plots, histograms, box plots, etc. Multivariate non-graphical. Multivariate data arises from more than one variable. Multivariate non-graphical EDA techniques generally show the relationship between two or more variables of the data through cross-tabulation of or statics. Multivariate graphical. Multivariate data use graphics to display relationship between two or more sets of data. The most used graphic is a grouped bar plot or bar chart with each group representing one level of one of the variables and each bar within a group representing the level of the other variable. Now, exploratory data analysis language. Some of the most common data science programming language used to create an EDA include Python and R language. An interpreted object-oriented programming language with dynamic semantic, its high-level built-in data structure combined with dynamic typing and dynamic binding make it very attractive for rapid application development as well as for use as a scripting or glue language to connect existing components together. Python and EDA can be used together to identifying missing values in a dataset, which is important so you can decide how to handle missing values for machine learning. Programming language R, an open source programming language and free software environment for statistical computing and graphics supported by the R Foundation for Statistical Computing. The R language is widely used among statisticians in data science in developing statistical observation and data analysis. So, we took a brief overview of what is exploratory data analysis. Now, we can talk in detail about exploratory data analysis with the following points. So, first, exploratory data analysis. This is the definition of exploratory data analysis. We go through the points is EDA versus ST. EDA is an approach to analyzing data sets by visually and quantitatively examining the underlying structure of the data. It is mostly unstructured with the goal of discovering patterns, spotting outliers, and checking assumption through visualization and descriptive statistics. EDA is typically used to inform decision about the choice of models, transformation, and other steps in the data analysis process. Hypothesis testing (HT). Hypothesis testing is a formal statistical procedure for testing a hypothesis about a population parameter based on sample data. ST is more structured and focuses on testing predefined hypotheses, usually with the goal of proving or disproving a theory of or assumption. EDA is often used as a precursor to ST, allowing researchers to understand the data and generate hypotheses before formal testing. Now, bar graph with response overlay. Bar graph are a standard method to visualize categorical data. A response overlay adds another layer of information to this visualization, typically in the form of summary, static, or distribution for each category. So, guys, this is the Python program of constructing a bar graph using Python programming language. Now, we talk the point about contingency tables, a detailed overview on the contingency tables. A contingency table, also known as cross tabulation or two-way table, is a powerful tool in exploratory data analysis, primarily used to analyze the relationship between two categorical variables. The table displays the frequency of different combination of categories across the two variables. It's particularly useful for examining how the values of one categorical value variable vary across the level of another. For example, if you are interested in studying the relationship between gender and smoking status, a contingency table would show how many males and females are smokers versus non-smokers. So this is our Python program by how to construct the contingency tables. Data is equals to pd dot data frame variable 1 variable 2. Contingency table is equal to pd dot cross table data variable 1 data variable 2. Print contingency table. So this is our fourth point, histogram with response overlay. A histogram is a type of bar chart that represents the frequency distribution of a continuous variable by dividing the data into intervals or bins. It is used to give an overview of the shape, spread, and central tendency of a dataset. A response overlay refers to adding an extra layer of information to the histogram, often to visualize the distribution of a categorical or binary response variable alongside the continuous variable. The concept of histograms with response overlay allow us to compare how different levels of a response variable, such as binary outcome like success versus failure, are distributed across the means of a continuous variable. For example, imagine you are analyzing a dataset that records the age of individual and their smoking status. By overlaying the response variable on the histogram of age, you can compare the distribution of ages for smoker and non-smoker in a visually intuitive way. Binding based on predictive value, a detailed overview. Binding based on predictive value is a technique used in data pre-processing and feature engineering where a continuous variable is divided into discrete intervals based on their relationship with a target variable. This technique is particularly useful in machine learning and statistical modeling as it helps improve model performance, interpretability, and stability. The goal of binding is to group similar values of the continuous variable together in a way that is predictive of the target variable. So, why we have to use binding based on predictive value? Binding can be useful in variety of scenarios. Improve model performance, reduce outliners impact, enhance interpretability, feature engineering, handle non-linear relationship. So we can go through the detailed overview why we use binding based on predictive value. Improve model performance. In some cases, models may perform better when continuous variables are discretized into bins, especially when the relationship between the predictor and the target variable is non-linear. Reduce outliers impact. Binding helps reduce the impact of extreme outliers by grouping values into wider intervals. Enhance interpretability. Models that work with discrete variables can often be easier to interpret. Binding turns complex continuous features into categorical like variables. Feature engineering. Binding allows the creation of new features that might capture important interaction between continuous and categorical variables. Handle non-linear relationship. Some algorithms like decision tree can capture non-linear relationship between the feature and target variable more effectively when features are bind. Types of binding. Equal width binding. There are mainly three types of binding: equal width binding, equal frequency binding, custom binding, which is also called predictive binding. Equal width binding. The range of the continuous variable is divided into intervals of equal width. Example, if the range of the variable is from 0 to 100 and you want 5 bins, each bin would have a width of 20. Example, if the range of equal frequency binding. The data is divided into intervals such that each bin contains the same number of observation. Example, if you have 100 data points and you want 5 bins, each bin will have 200 data points, but the width of each bin will vary depending on the distribution of the data. Custom binding, which is also called predictive binding. This method means the data based on the predictive relationship between the continuous variable and the target variable. It uses a statistical technique to create bins that are most predictive of the target. This method often involves using technique like decision trees or chi-squared statistics to define the bin edges that maximize predictive value. So, with the help of following points, we cover the full topic of our exploratory data analysis. Hope you guys like watching this video. If you find this video helpful, please like our video, subscribe our channel, and share this video with your friends. Thank you.